onto? Well, to check that, we just need to see which direction the player was moving to begin with. So I'll add another comment to say check which side the collision is from. And the direction in which he's moving is just determined by the dx variable, because when he's moving to the right, dx variable is positive, so it's greater than 0. And when he's moving to the left, it's less than 0. So if he's moving to the right, and therefore this variable is more than 0, then we want to make sure that he doesn't go through the wall. So when a collision is detected, we push him back against the edge of the wall. So the player's rectangle's right-hand side is equal to the obstacle rectangles, which is index 0, left-hand side. And then we just repeat this for the opposite movement. So if he's moving to the right, we've taken care of that. Now if he's moving to the left, then the dx variable is less than 0. So now it's self.rect.left, so it's the player's left-hand side, is the same as the wall's right-hand side. So let's just test this out. Now we've only got left and right collision, so let's move left-hand side is the same as the wall's right-hand side. So you might be wondering what all the animation as well as a coin, like a big coin in the background. So it's partially working. It is showing the coins where they should be, but it's still showing this big coin, which was just the image that's used by the level editor tile. And that should apply everywhere else. There we go. Okay, so we've got the coins working, so let's move on to the next item. And that's going to be the potion, item 10. So I can actually, here initially, we actually had to wrap the red potion through that entire, and before I actually get into it and the enemies within here, or potion to be used as starting positions for them, because that's how I've positioned them in the level editor. That's essentially how I work out where to put enemies, where to start the player off, and where the start and finish will be. So we process that in the same way. We go back into the world class here, and before I actually get into all that, I need to make sure that I import the characters from the top here. So let's just say before we import the items, I kind of just order them in order of importance. So I think the characters are more important than the items. So we say from character, import the character class. Because now I'm going to be calling the character class within this text here. So just the same way as I created coins as an instance of the item class, and the same with potions, I'm going to create the player and the enemies within here rather than manually creating them within my main file? Well, the player should be tile number 11. So if we go to the next tile, tile number 11 is our little character. So we can add another elif statement here. We'll say elif tile is equal to 11, and that means that we want to create the player character. So let's go over to how he's being created within this main file, and let's just cut this out of here. Or rather, for now, we'll leave it there, but we'll just copy it, just to save us typing it again. So we go in here, paste it in. So the player is going to be an instance of the character class we've just imported. The x and y coordinates need to be replaced with image x and image y. So let's put that in place of these two. Next comes the health variable. Well, I want to start them with full health, so 100. And then we need to pass through mob animations. Well, that is not part of this file here. So we need to add, or we need to pass mob animations as an argument within this process data method. So let's go to the top here and make sure that we pass them through as an argument. And then we go back into the main file and make sure that we pass them through as an argument. So we scroll up, this is where we're creating the world and we're processing the data for it. So after images, we just add a comma and say mob underscore animations. So now we can continue with the other arguments. So mob animations will just be taken automatically here because it's being passed through within this process data as an argument. Then the next thing is the mob type or the character type, which for us, for the player, is going to be 0. And then just like I did with the exit tile, I want to store this player as a variable within this world class. So we come to the top here and we'll say self.player is equal to none. And then we just override it within this section here. So once we created the player, we assign it to the self.player variable. So self.player is equal to the player that we just created. And now that we've done this, let's go back to the main.py file. So we're processing the data here, and as a result of this, we will have created a player within the world class instance. So let's scroll down to where we're creating our player manually. And now we can replace this section and we can just say world.player. So I don't actually need to return these arguments. I mean, I could return player instead. So I could add a return function to the end of this method and return all this information back. I don't actually need to return these arguments. I mean, I could end of this method and return all this information back, but I don't need to. It's being stored within this class, so I can just call it through and copy it into my main.py file. So now let's just see if this works. First of all, we'll run this, and now the player does appear where his tile is. So you can see he's perfectly positioned there. But when I move around, you can see that underneath is still the little image of where he should be sitting. So I need to do the same thing that I've done with the coins and the potions. I need to override the image of the tile underneath the player. So we just copy this line down here, and that will update the image to just a blank floor tile. So now the player appears, but underneath him is an empty floor tile. So now the only thing that remains within this world class is just to add in all the remaining tiles. So we've gone up to tile number 11, but we've got 18 tiles in total. So number 12, if I flick through, is the little imp. Number 13 is a skeleton, 14 is this little green goblin, and so on. So I can keep going. 15, 16, and 17 is this last big dude. So here we will say L will change to mention that here and append in between. So just to keep the format the same way as I have with the rest, I'm going to add that in between these two lines. So we'll say self.characterList.append enemy. And now we should be able to process this within our main.py file. So at the moment, I'm manually creating the enemies. Let's delete this line. So we've created, let's just tidy this up actually. So we create the player first of all, then we'll create the weapon straight after. And we'll say create enemy empty list. Well, actually we don't need this anymore. So we can just get rid of this line, update the comment to say extract enemies from world data. So now the enemy list is no longer a blank list, it's actually just world.characterList. So it's the list that we created within there, and we're pulling it through into here. So let's run this and see what happens, and there we go. So this little imp character has appeared in the exact same place that I specified him. Then the rest haven't been processed yet, so they're still showing up as these still images. So now all that's left is just to add in the rest of these tiles. So the next one is going to be pretty much a copy of the one above. So let's copy this down and we'll replace this with elif being equal to 13. Then enemy is a character. Now we create which the thing is that one equal to me. Got this red is a close one equal to just include the enemy. So actually use depending on the tile for L. So I'll set this to be equal to 17, and then I can just change this to 17 minus 11 to true. So the last one is going to be a boss. So if I go through and run this again, there can't be have it as going through correctly, but and we have he's quite a lot bigger as well than the normal as a boss item differently because he's the boss enemy. But I now know that this one is being created. Determined is okay. So it's active boss item also is just a place item in the back of the see his let's go. But for the boss enemy, the size is going to be 2, so he's going to be twice as big as everyone else. See his rectangle tile square level. So our tiles are all being processed here, depending on which tile it is. And just at the very end, I'll actually leave a space here because it's a slightly different section. We just assign whatever image it was into the tile overall tile map. And that's it. That's the process now automated. So let's just test this out. Now we've only got left and right collision. So let's move along left. And there you go. He stops. It looks like he continues the running animation, but he doesn't move it. Now I also don't have up and down collision yet. So we've got part of the way there. Now we go back into the character class and we just repeat the process for the up and down collision. So I'll add a comment here, or I'll just copy the one from above here to say check for collision with map in Y direction. So first of all, we move the player's right here. So I'll add a class and we just repeat the process for the up and down collision. So I'll add a comment here, or I'll just copy the one from above here to say check for collision with map in Y direction. So first of all, we move the player's rectangle and then we just do the same thing. We iterate through all the obstacles. So I'm actually just going to copy all of that down again. And we go for obstacle and obstacle tiles. We check for collision with the rectangle and then we check which side the collision is from. Except now, instead of dx, it's dy that we're checking against. So if dy is greater than 0, then that means that he is moving down the way. So the player's or the character rectangle's bottom side needs to be the same as the wall's top side. And if he's moving up the way, dy variable is less than 0, then his top side is equal to the rectangle's bottom side. So let's run this again. And now we should get pretty good collision. So we can run all through all of these edges, slide along all the walls, and we can go as far as the walls allow us, but no further. Greater than 0, then that means that he is moving down the way. So the players or the character rectangles bottom side needs to be the same. So collision is equal tiles. We check for collision with the rectangle. And we'll just copy the one from is less than 0, positive, world dot rect variable and all of those tiles rectangles. And this can be done with the collide rect function. So before I get into the code, I'm just going to explain how this works. Now, like additionally, there is passing variable we have to on the D here, because we already have a section here where we're ever. That means we need to pass them through into our character's move method as an argument. So we go back into our main.py file and we scroll down to where we are calling that move method. So that should be near the top here. So move player, and at the moment we just have player.move and we're given the dx and dy variables. So just after that we will say world.obstacle tiles. Now we can go back into the character class, go to the move method and add that in as an argument. So we receive the obstacle tiles variable or argument here, and now we can use it for our collision. So we'll come down here where we're just updating the player's positions based on dx and dy variables, and we're just going to expand it a little bit. So first of all, I'll add a comment. So index 0 is the character. To the left. Left, it's less than 0. So if he's moving to the right and therefore this variable is more than 0, then we want to make sure that he doesn't go through the wall. So when a collision is detected, the hand side is equal to the obstacle rectangles, which is index 0, left hand side. And then we just repeat this for the opposite movement. So if he's moving to the right, we've taken care of that. Now if he's moving to the left, then the dx variable is less than 0. So now it's self.rect.left, so it's the player's left hand side, is the same as the wall's right hand side. So let's just test this out. Now we've only got left and right collision. So let's move along left. And there you go. He stops. It looks like he continues to running animation, but he doesn't move anymore. And then we can go to the left and the same works there. Now we can move up and down. And you can see that the collision works as long as we're continuing to move left or right. But if I let go of the A key, for example, as I'm doing this, you see there's some weird things happening. I also don't have up and down collision.